Namaste children, we are back to the chemistry class. Last time in the chapter matter around us, we studied the classification of matter. I am just showing you, just see it on the board. On the basis of physical state, we classified the matter, which is anything that occupies space and has mass, is classified as solids, liquids, gases, plasma, and Bose-Einstein condensate. Okay? Fundamentally, there are three types. There are solids, liquids, and gases. And in addition to that, scientists have created two more physical states, creating certain conditions. Okay? Like plasma is an ionized gas which is stored in presence of magnetic field, whereas Bose-Einstein condensate, the last one you could see, there are five here, the last one, Bose-Einstein condensate, is the one which is created by these two scientists. What they did is that they have reduced the temperature of a gas to an extremely low temperature. Okay? So they could get such a state where those gases start behaving differently. So that's why they said it has Bose-Einstein condensate after their names. Fine? So we have also studied the differences between the three fundamental states of the matter on the basis of their physical states at given temperature and pressure conditions. Okay? So we studied the differences between solids, liquids, and gases in terms of their fluidity, intermolecular forces, rigidness, density, okay, shape, etc. Okay. So after that, we have another classification. Now I am showing the another classification of matter as pure and impure substances. Okay, matter as pure and impure substances. Now impure substances are nothing but mixtures. Okay, impure substances are nothing but mixtures. That means you will have more than one type of substance. Maybe sugar plus water, sand plus gravel. Okay, soil consists of mixture of salts. Okay, soil itself is a mixture, consists of several types of salts. So they are all in the category of mixers. Okay, they are impure substances. Mixers can be easily separated from each other by some techniques known as filtration, hand picking. Your mother at home must be doing hand picking of separating earthen particles from the rice. Okay. To make pure, rice particles, we separate sometimes stones and earthen particles. So that is nothing but hand picking. Okay. So similarly, you can do hand picking as a method of separation of mixtures. You can use filtration method. You can use boiling also to separate mixtures. You can use distillation, simple distillation, fractional distillation, distillation under reduced pressure, chromatography, solvent extraction, and so on. These are some of the methods of separation of mixers. We have this topic, we will be studying the details of methods of separation of mixers in the later stage. Okay. Now, in the same class, in class 9th we have this. And this class I am taking is for classes 6 to 9. Okay. So from 6th onwards you will be taking up these topics. Now, again coming back to the mixers, as you know that mixers are two types. Earlier also I said these impure substances mixers are of basically two types. First is homogeneous and second is heterogeneous. Second is heterogeneous mixture. Here slight change I am doing here in heterogeneous. Okay, heterogeneous mixture. So homogeneous mixers and heterogeneous mixers. Today children, I will show you the demonstrations of all these homogeneous and heterogeneous mixers using some chemicals. Okay, so I will explain you through demonstrations how a homogeneous mixer looks like, how a heterogeneous mixer looks like. Sugar in water, examples: common salt in water, baking powder in water, because these are all the substances which are fairly soluble in water, which makes a homogeneous mixture where the distribution of particles will be uniform throughout the mass. Earlier explained, I will demonstrate today. Practically I will show you. Heterogeneous mixtures are very clear, very easy to understand. Sand in water, okay, chalk powder in water, gravel in water, they don't get dissolved. So they look different. You can see sand particles separate and water separately. I mean, you can see them differentiate. And even if you put chalk powder, it gets settled down, it doesn't get dissolved. Okay, chalk powder in water. Okay, so there are so many such insoluble substances which makes the solution heterogeneous. We don't call it as even solution, it's simply a mixer. Okay, that is known as heterogeneous mixer, where the components can be seen and will not be homogeneous, it will be heterogeneous. That means distribution of particles will not be uniform in heterogeneous mixers. So whenever we talk about homogeneous mixers, they are basically solutions. They are basically solutions. Solutions are homogeneous mixers. Okay, solutions are homogeneous mixers. When you make a homogeneous mixer, it is not necessary that you mix only two components or two substances. You can mix more than two substances as well. And if you mix two components like A plus B, it is known as binary solution. Of course, I'll tell you what exactly the solution is. Solution is a mixer, because it's a homogeneous mixer. Homogeneous mixer of two or more components is nothing but solutions. Okay, solutions are homogeneous mixture of two or more components. Very simple. Okay, mixture must be homogeneous, thoroughly dissolved in the given solvent. Okay, so that is solution. Now if two components are there, that means one that gets dissolved, that is known as solute. I am explaining three terms here. I will demonstrate all these things. I will show you what is solute, I will show you what is solvent. For example, sodium, I will dissolve sugar in water and I will show you that this sugar is solute and solvent will be water. Generally water is said to be the universal solvent because water dissolves most of the chemicals available in the universe. Surprisingly, water dissolves most of the chemicals available in the universe. So, water is said to be the universal solvent. Okay. So, solute is the substance that gets dissolved. Solvent is the one which dissolves. The one which dissolves. ఏదైతే dissolve చేస్తుందో దాన్ని solvent అంటాం. That is especially water. Okay, in most of the cases the solvent is water. When the solvent is water, then we call it as aqueous solution. Aqua means water, aqua means water. Aqueous solutions are all the solutions which are prepared in water. Aqueous solutions are all solutions which are prepared in water. Aqueous solution of sodium chloride, that means sodium chloride dissolved in water. Aqueous solution of baking powder dissolved in water. Okay. Now, if I am preparing a solution in some other solvent like alcohol, alcoholic solution of sodium hydroxide, that means a solution is prepared by dissolving sodium hydroxide in alcohol, not in water. I can also prepare aqueous solution of sodium hydroxide. In that case, I'll dissolve sodium hydroxide, which is a solute, in this solvent water. If I dissolve it in water, it will become aqueous solution. If I dissolve it in alcohol, it will become alcoholic solution. But whenever we study solutions, mostly we use aqueous solutions. Okay, children, let me tell you, there is a chapter named solutions in your class 12th, okay, which is a very, very important chapter of class 12th, which carries 5 marks in CBSE exam, and almost the same weightage is there in your AP board, intermediate board as well. Okay, so I'll explain again with the help of demo what are these solute, solvent, solubility also I'll explain. Solubility I'll demonstrate the solubility of substances also. Binary solutions, I'll make binary solution. I'll prepare by adding one component in one solvent. So A plus B, that will be a binary solution. If a solvent plus solute is there, A symbol is used for solvent conventionally. A stands for solvent conventionally. These are the symbols used, and we will have to use these symbols conventionally forever whenever we talk about solutions. Ternary solution. Ternary solution means you will have 3 components. See, A plus B plus C. So A is always a solvent and B plus C are solutes. Okay, like this. So now and then quickly I'll tell you, this is what are the impure substances. Impure substances. I'll give demonstrations of explaining all these impure substances with examples. Okay, then pure substances are on the other side of the whiteboard. I'll explain them in detail later on, but simply I'll just tell you, basically pure substances are classified as elements and compounds. Okay, I hope you can see clearly elements and compounds. Now elements examples you see: iron, carbon, oxygen, hydrogen, germanium, copper, silver, gold, etc. Phosphorus, sulfur. In these elements are the pure substances, you know that, which cannot be further decomposed by any means. We studied those definitions also. Okay. Now, elements are again classified as 3 types: metals, semi-metals, and non-metals. Elements are classified as metals, metalloids and good antaru. Metals, metalloids or semi-metals, and the third one is non-metals. So metals, you know, copper, iron, gold, silver, okay, cadmium, titanium, etc. Uranium, polonium, radioactive metals. Metalloids I have written here: boron, silicon, germanium, arsenic, antimony. SB is for antimony. Actually its name is stubnum. Okay, the Greek name. That's why SB is written. Actually it's named as antimony, but its symbol is SB because it's derived from stubnum. Then tellurium, polonium. You know, there are only 7 semi-metals. You can clearly see this. Only 7 semi-metals. Then there are non-metals, around 17 non-metals. You don't have many non-metals as well. Only 17 non-metals. Some of them are carbon, nitrogen, oxygen, fluorine, chlorine, sulfur, phosphorus, bromine, iodine, astatine. Okay, then helium, neon, argon, krypton, xenon. So this is there are 17 non-metals. only 7 semi-metals, and finally you have rest of them are metals. Almost 94 metals are there. So 94 plus 7 plus 17. So total it constitutes 118 elements. So these elements are indeed classified as metals, metalloids and non-metals. Okay. Now there are 7 semi-metals, 17 non-metals, and rest of them are metals, somewhere around 94. So total 118 elements so far. Then pure substances are classified as I told you, elements and compounds. Now elements we have done it so far. Then compounds are again classified as organic compounds and inorganic compounds. Then one more classification is there, stoichiometric and non-stoichiometric. I'll explain them later on. Basically compounds are also pure substances which are formed by the chemical combination of 2 or more elements combined in a fixed proportion by weight. Whenever compounds are formed, the elements combine in a fixed proportion by weight. Examples: water, ammonia, baking powder, sugar, etc. So anyway, I will explain this pure substances later. Before I go to the pure substances, first we will finish with the demonstrations of impure substances mixtures. So in mixtures, homogeneous and heterogeneous mixtures we will study, and we will study solutions. Okay. Solutions is a very important topic, so I will give some more details of solutions which may not be in your book, because this is going to be a very important lesson, and this topic is linked everywhere, be it physical or organic or inorganic chemistry. Wherever you go, they talk about the formation of some solutions. Many chemicals exist in the form of solutions, and when we carry out reactions, we need to prepare solutions. In solid state, sometimes reactions will not happen. In many cases, in solid state, reactions will not happen. In most of the cases, we will have to prepare solutions. Then only reactions takes place. So the solutions topic is so important. Therefore, what will I do is I will give some details. I will certainly give some more details of the topic solutions. Okay. Classification of solutions I will explain. There would be 3 types of classification other than homogeneous and heterogeneous. Okay, homogeneous and heterogeneous mixers we have already understood. Now I am going to demonstrate them and also explain different terms involved in solutions. Okay, take a break. I am going to start live demonstrations of different solutions.